Splitting a hard task across a swarm of agents sounds obviously better than one. More brains, more parallelism. In practice, it often comes out slower, pricier, and less reliable than a single good agent. Knowing exactly when the split pays off is the real skill. Let's start
plainly. When does splitting a task across several agents actually beat just using one capable agent? What has to be true? You have 10 seconds to think.
The task has to genuinely break into pieces that don't depend on each other. If you can hand 3 agents 3 independent sub-questions and they barely need to talk, you win, mostly because of context, not raw brain power. Each agent gets its own clean, focused window instead of one model drowning in everything at once, and together they can hold far more than a single context window could. So the sweet spot is breadth. Read-heavy work, searching across many sources, exploring several directions at once. A deep research task is the poster child. Fan out, each agent digs one thread, then someone gathers the findings. The pattern that helps isn't more brains debating. It's parallel, isolated context covering ground no single window could hold. If the task doesn't fan out like that, one agent is usually the better call.
Right, when it fans out. Say it does fan out. What are you paying for that parallelism? What's the cost side of the ledger? You have 10 seconds to think.
Three things, mainly. First, tokens, a lot of them. A single agent already burns far more than a chat, and a multi-agent setup can run on the order of 15 times a chat's usage because every sub-agent rereads its instructions, context, and tools. So it only makes sense when the task is valuable enough to justify that bill. Second, communication is lossy. Agents can't share their full state, so they pass compressed summaries to each other, and whatever didn't fit the summary is just gone, which is where a lot of subtle mistakes sneak in. Third, latency and orchestration. Someone has to split the work, route it, wait for the slowest agent, and merge results, and that coordination layer is itself code that can fail. Parallelism isn't free. You're trading money and coordination for breadth.
Now the one that bites people. Multi-agent setups often end up less reliable than a single agent, not more. Why does that happen? You have 10 seconds to think.
Error compounding. Reliability multiplies down a chain. If each agent is, say, 95% reliable and you chain 5 of them, you're well below 90% end-to-end, and that's the optimistic case. The nastier version is silent. An agent produces something structurally fine but subtly wrong. The next agent faithfully treats it as correct, builds on it, and the whole system reports success while the answer is quietly broken. No single place through an error. And because the orchestrator usually only sees each agent's summary, not its full reasoning, those mistakes are hard to even spot. Unstructured setups can amplify errors many times over a single agent, not a few percent worse, multiples worse. So more moving parts doesn't average out the noise. It stacks it, unless you add real checks between the handoffs.
Let's make it a decision. You've built a multi-agent system and it's measurably slower and less reliable than a single agent doing the same job. How do you decide whether to collapse it back? You have 10 seconds to think.
First, I'd make sure I even have the baseline, a single strong agent with good context management, because that's the thing to beat, and a lot of teams never measure it. Then I'd ask whether the work is actually parallel or just dressed up that way. The tell is shared state. If the subtasks are independent and mostly read-only, like gathering information, keep the fan out. If they constantly need each other's intermediate results or they're all writing into one evolving artifact, most coding falls here. That coupling is exactly what handoffs handle badly, and I'd collapse those parts into one agent. Often the answer is partial. Keep a single parallel fan-out step for the breadth. Pull the tightly coupled reasoning back into one agent. Collapse wherever the coordination tax and error stacking outweigh what parallelism buys you.
Last one, the clean rule. Give me your default. Where do you actually reach for multiple agents, and where would you refuse to split no matter how tempting? You have 10 seconds to think.
My default is one strong agent with carefully managed context. It's cheaper, easier to debug, and more reliable. I reach for multiple agents only when the task is high value and genuinely fans out. Breadth-first research, information that overflows a single context window, lots of independent sources or tools to hit in parallel, with clean interfaces between the pieces. That's where isolation and parallelism earn their keep. I'd refuse to split a single coherent thing that needs one consistent picture, writing one document, or a coding change where every part touches the others. Forcing that into separate agents just buys you lossy handoffs and compounding errors. So fan out for breadth and independence. Stay single for depth and tight coupling. The real question is always whether the task truly decomposes, not whether more agents sounds impressive.
So, pulling it together, multi-agent wins when a task genuinely breaks into independent, read-heavy parallel pieces that overflow one context window. Its real trick is giving each agent a clean, focused context. It loses when the work is coupled and shared, because handoffs are lossy and small errors compound down the chain while the system still reports success. Default to one strong agent with good context. Reach for many only when the task truly fans out. If this kind of prep helps, like this episode, share it with someone who's interviewing, and subscribe to Interview on Your Way. More and better questions are on the way.